going to do question 10, where we are given a piece of cardboard with an area of 1,350 centimeters squared, is folded to form a closed rectangular box with a square base, right? The side of the square base is x centimeters and the height of the box is h centimeters, right? So this is the shape of the box, and then if you can see the base, it's x and x, so x even there and there. So now they say determine the value of, so that is the question says determine the value of x for which the volume will be a maximum. So for us to solve this problem, we need to first find the volume, right? Yes, we are given the volume, but let's find the expression of the volume. We know the volume is equals to we're going to use the base, area of base, okay. So for us to solve this problem, we need to find the volume of this shape here. But for us to find the volume, we need to use the area that we are given. We're going to use the area that we're given. Let's first try to write the equation of the volume. Volume is equals to area of base times height, right? So the area of base times height. But let's first use the area of the cardboard to find other expressions of the problem. So its area is equals to 1350, right? But what is the base? The area of the base, it's a square. So area of the base plus the area of the rectangle, right? The rectangle, which means these sides here, all four sides, because if you look at this shape, it has four sides. It has 1, 2, and this 3, and this 4 here, right? And then the base, it's 1, 2, right? So area of base, so we have 2 base, 2 area of base. So this is area plus how many sides of that are rectangular? There are 4. So you're just gonna say 4 areas that are rectangular, right? So this expression here is equals to this number here, right? To write it properly, I would say 1350 is equals to 2a of b for base plus 4a of r for rectangular, right? So 1350 is equals to 2. What is the base? Base is x, right? We were told that the base has x, and it is square, so it's a square base. So it's going to be x, which is the length times the breadth of the base, which is x, right? So, and then plus for the area of the rectangle, it's going to be the x, which is the base, this one here, and the height that is of the rectangle, which is h, right? So if you write this properly, you will have 1350 is equals to 2x squared, this portion here, plus 4xh, right? So we're going to write this expression with respect to or in terms of x, right? With respect to x, but equating it to h. So we take this to the other side. We have 1350 minus 2x squared is equals to 4xh. Divide by 4xh, divide by 4xh. Then our h is equals to 1350 minus 2x squared over 4xh, right? So this is one part of our shape, our rectangular box, right? So which is H, and it's this one here, so this is equal to this. So now because we want the volume, the area we already found now, or the parts of the area, right? So if we were to find the area of this rectangular box using expressions, so the area of base is x squared, right? Because it's the square base, right? And then you're going to multiply it with the height of this rectangular box. So meaning your volume will be equals to x squared times h, and our h we already found here, right? So let me write this properly. So we have the volume being equals to x squared times h, but h is equals to 1350 minus 2x squared all over 4x, right? So if we substitute, we have x squared into 1350 minus 2x squared all over 4x, right? So if you simplify it, x squared into 1350 all over 4x minus 2x squared over 4x, right? So we'll have x squared into 1350 over 4x minus, so this x will go away with that one. You will remain with, and then these two will divide out with this, so you have x over 2. So this is the expression of the volume, right? So the volume is equals to that. So now you're going to multiply the x squared inside, right? So it's going to be volume is equals to 1350x squared over 4x minus x times x squared over 2, right? So the volume is equals to 1350, so the x and the x, excuse me, and the x squared will divide out, so you have x over 4 minus x cubed over 2, right? And we're asked to find the value of x, right, such that this volume is to the maximum, right? So for us to do that, we need to derive this, right? But before we derive, 2 goes how many times? Here it goes twice. 2 goes how many times? Here it goes 675. So the volume will be equals to 675 over 2x minus x cubed over 2, right? So if we derive the volume with respect to x, it's going to be 675 over 2 minus 3 over 2x squared. So now we're going to equate the derivative to 0. So it's going to be 0 is equals to 675 over 2 minus 3 over 2x squared. And then we transpose the 3 over 2x squared. It's going to be 3 over 2x squared is equals to 675 over 2. And then we cross multiply, so we have 3x squared is equals to 2 times 675 over 2. Then this goes away. We remain with 3x squared is equals to 675. Right, and then we divide by 3 both sides, divide by 3, and then x squared is equal to 675 over 3, right? And then we put the square roots both sides and finding the x solution. So x is going to be equals to 15. So this is the value of x for this problem here.